So good morning or good afternoon, everyone, depending on where you're joining us from. My name is Jesse, and I am with the seat of your pants. So for those who don't know, we are all about bringing conservation, adventure, and science into classrooms around the world. And we're really excited because all November long, we are doing hangouts related to space. We have astronauts, astrophysicists, astro everything, basically. It's been a lot of fun, and thank you so much for joining us early on in the month. Right now, we've got 6 classes joining us from across North America. So I'm going to give them a chance to do a bit of a shout out before I introduce our speaker. We've got Miss Caesars, grade 6s in Prince George, BC. Hi, guys. Our only Canadian class for today. We've got Miss Creeches, grade 5s in Freehold, New Jersey. Hi, guys. All right, that one kid is super excited. We've got Miss Zamora's first Lego robotics team, grade 5s in San Antonio, Texas. Hi, guys. All right, they broke the mic. They were so loud. We've got Miss McCrell's grade 6s in Herndon, Virginia. I don't know if their mic's working, but they're excited, and that's all that matters. All the hands went up. We've got Mr. LeVogue's grade 8s in Palm Beach, Florida, who will need to demute their own mic, but they're excited too. And we've got Miss Williams, 4-5s in San Antonio, Texas as well, just pouring in. Hi, guys. All right. Of course, the reason you guys are all here today is for our speaker. So we are joined live at the NASA's Jet Propulsion Laboratory in Pasadena, California by Dr. Abigail Fraeman. So the Jet Propulsion Laboratory is one of the most storied and important research centers in the entire world. Dr. Fraeman is a planetary scientist who works for them. So she gets to send rovers and satellites to all the other places in our solar system, our neighbors out in space, and explore them and see what they have to offer for the very first time of anyone in the entire world. So it's one of the great jobs on Earth. And without further ado, I'm going to turn it over to her to show us what she does. Thanks so much for joining us, Dr. Fraeman.
Awesome. Thank you so much for having me, and thank you for that excellent introduction. I'm so excited to get to speak to you guys today and tell you a little bit about what I do here working at NASA at the Jet Propulsion Laboratory, and hopefully answer some of your questions about what it's like driving rovers on Mars. I went ahead, I made a couple slides just to show some pictures to you all. So I will disappear myself, and let's see if I can share my screen here. Pop that up. Right, and hopefully I'll show you a little bit about what I do. But going ahead, can you see what my slide?
Yes, we can. Yep, we're good.
Great. So this is a picture of where I'm talking to you guys from today. This is NASA's Jet Propulsion Laboratory. We're located in Pasadena, California, so right outside of Los Angeles. It's a pretty big campus. It's kind of like a college campus, and I put a red arrow that's pointing to my building. That's the science building, but there's lots of buildings here. We have people who work here like me who do science. We also have a lot of engineers who work here who work on building robots and rovers. We have business people here who help us manage all of our contracts. All sorts of people work at JPL. It's a little bit confusing to talk about the difference between the Jet Propulsion Laboratory, or JPL, and NASA. And in actuality, the Jet Propulsion Laboratory is one of many different centers that NASA has around the United States. So you can see here's a map that's labeling where everybody's located. So I circled where I am out in California on the West Coast, but you can see that NASA has centers all over the country. A couple of you guys I hear are from Texas. The Johnson Space Center is located in Texas. So if you're familiar with kind of the famous movie lines, Houston, we have a problem. That's because those lines are said by astronauts who are talking to Johnson Space Center. And that's the center that's responsible for all of the astronauts and the human exploration. From Virginia, we have Langley Research Center. So if you guys saw the movie Hidden Figures, or you heard of that movie, that took place at Langley Research Center, which is another branch of NASA in Virginia. If you think about a lot of the rocket launches we do, the space shuttles, some of the SpaceX launches, those all happen out of the Kennedy Space Center, which is located in Florida. But here at the Jet Propulsion Laboratory, we specialize in robotic exploration of the solar system. And in particular for me, I specialize in robotic exploration of Mars. Mars, we all know, is called the red planet. It looks pretty red. It's our next door neighbor. It's the next planet furthest out from the sun. And I'm really interested in working with the engineers here on building and sending robots to explore Mars, to study its rocks, and to understand its past. Why do we want to study Mars? Why do we care about this other planet that's not Earth? I think there's several important reasons. First of all, there's a lot of you who may have heard of the notion that we're looking for life on Mars. Right now, the only place in the entire universe that we know life exists is our planet, planet Earth. But we do wonder, could life have started anywhere else in the solar system? And we think if it did start somewhere else in the solar system, Mars might be a good place to look. We think early Mars was maybe once a lot like early Earth. So we wonder if the processes that started life on Earth also happened on Mars. And broadly, this is a really important question, because if we find that life started independently on Mars, then that would tell us that the process that starts life is pretty common, and we would expect it to be everywhere in the solar system. We haven't found life on Mars yet, but we're still looking. Another reason that we study Mars that I think is really important is even if we don't find life on Mars, it's still a really interesting place because it tells us something fundamental about how planets form and how they evolve. As I just said, we think early Mars was once a lot like early Earth, but today the surface of Mars is very, very cold. It's far below freezing. It's much colder than even, I hear some of you, Alaska or Canada in the winter. Mars gets way colder than that. It also doesn't have a very thick atmosphere. But we think in the past it was once a lot warmer and a lot wetter. And so we want to understand what were the processes that drove the planet to form the way that it formed. Why is it cold and dry today? And why is a planet like Earth warm and wet and a really good place for life? So we need to go to Mars to understand that. I think another reason it's important to study Mars is it gives us insight into Earth as a planet. And I think it helps us understand more about ourselves. We understand how geological processes operate on Mars, and that helps us better understand these processes on Earth. And this is a really beautiful picture. This was taken from one of our rovers that's on Mars, looking back towards Earth. So that's what Earth would look like from the surface of Mars. And then finally, I think one day humans are going to visit Mars. You know, maybe it'll be some of you guys. Hopefully it'll be some of you guys. And so in order to prepare for that human exploration of Mars, we need to understand what the Mars environment is like today in order to really understand how humans could go there and survive. Where could we land where we might find resources that would have water that we could use? What's the radiation environment like? What is the weather like? All of these questions are really important and questions we need to study in order to prepare for eventual human exploration. Now, to answer questions like this, we can go to Earth and do geology. And so here's a picture of me doing some of my favorite parts of my job, which is actually going out into the field myself and looking at rocks and understanding the forces that shape them here on Earth. Which also helps us understand some of the data that we're getting back from Mars. But as I said earlier, Mars is very cold, it's very dry. It's not a place that we are able to send humans just now. So we can't do this kind of geology on Mars. So instead, we send our robot geological explorers. Some of the robots we send are orbiters. So here's a picture of the fleet of orbiters that we've sent to Mars over the last few years. There's actually a couple more that we've sent that aren't represented in this graph that were sent slightly later. But this gives you a sense of kind of the instruments that we have that observe the planet. These orbiters take spectacular pictures of the surface of Mars. These are rocks that we see on the surface of Mars. Beautiful, beautiful layered rocks that were formed a really long time, probably several billion years ago. We also see lots of sand and these beautiful dune field and sand ripples blowing around and shaping the surface of the planet. And we also see really tantalizing, interesting sites that we think once had flowing water. So here's an image that we see from the orbiters, and the color on this image actually represents the sorts of minerals that are found in this environment. And as a geologist, what I can do is look at this image and look at the shape of the features in this image, and I see a feature that's called a delta. And this is the sort of geological feature that forms when you have a river that's running into a lake. So that tells me that there was probably liquid water at this particular site a long time ago when Mars's climate was very different. And the minerals that we can see using the orbital data, they're labeled these clays and these carbonates. These are very special materials that only form when you have very specific environments where you have water, and you have water that's probably going to be pretty drinkable and pretty good for life. So we see sites like this from the orbiters, and we realize that they'd be great places to send a rover to go explore closer on the surface, get a much more detailed view of what the rocks look like. And actually, this particular site, we're thinking about sending a rover in a couple years to collect some rocks that we would actually send back to Earth for analysis in our labs here on Earth. We've never done that with a rover before. It will be a first. But this is one of the rovers that I spend a lot of my time working on. There are actually two of them that look like this. They're a pair of rovers. They were called Spirit and Opportunity. They landed on Mars all the way back in 2004. So that's almost over 14 years ago. So these are pretty old rovers. One of the pair of rovers, Spirit, stopped functioning in 2010. But Opportunity, we're still hoping to hear from today. These rovers were designed to last for 90 days. And so they've definitely lasted way past how long they were designed to last. These rovers are pretty great, and they serve as our geologists on Mars. They have a lot of very special science equipment that is basically analogous to what we would use as a geologist in the field here on Earth. So they have a bunch of cameras on the top of the mast that can take pictures of the rocks. We have a camera on the end of the arm that can get up close to the rock and look at the really fine detailed textures. We also have a grinder on the arm, which is kind of analogous to a geologist rock hammer. We can use this grinder to break open rocks and look inside them and see the surface of the rocks that's maybe not as weathered or as exposed to the environment. And of course, we have an antenna to send all of this data back to Earth so that we can record what we see in our field notebook. This is a picture of Opportunity exploring an area called Victoria Crater. The rover itself is drawn in by an artist. The rover can't take a picture of itself exploring, but the images you see are real pictures from the surface of Mars. And at this particular site, we drove all around the rim of this crater. We drove up and down this wall of rock, and we studied what we saw on the wall to try and understand what the past environment was like. Looking at the rocks, we saw some things that look like this, these little kind of round-looking spheres. They're not alien eggs, if that's what you're thinking. They're actually geological formation that have a lot of iron in them, and they form in the presence of liquid water. So integrating all of the results that Opportunity found at this site, we were able to back out kind of the scene of the crime to understand that a long time ago, probably about 2 billion years ago, this area on Mars looked a lot like this area on Earth. We probably had a little bit of very salty water coming up out of the ground, and that's what formed the rocks that we saw. Now, I mentioned that we're hoping to hear from Opportunity, but we had a pretty intense event that happened a few months ago, back in June, when we had a dust storm that started to pick up. Mars is a very dusty place, and occasionally in the summertime, we have these giant dust storms that come through, and sometimes they're so big, they cover the entire planet. And this is what happened back in June. We had a dust storm that kicked up, and it covered the entire planet, and it made the skies really dark and really dusty for about a month. So here's a picture of what the sun looked like in the middle of this dust storm, all the way on the left-hand side where I'm circling. This is what the sun usually looks like to the rover, but at the height of this big, massive dust storm that kicked up, this is what the sun looked like when I'm circling all the way on the right-hand side. So the skies got really, really dark. And it turns out this is a big problem for a rover like Opportunity, because we have solar panels that we use to charge the battery and give the rover energy. So when we don't see the sun because it's so dark and so dusty, we can't charge the battery on the rover, and then we don't have the energy we need to take our science observations or even communicate back on Earth. So this is what happened. We lost communication with the vehicle. We think the vehicle went into something called a low power fault, where it just kind of shut down and tried to conserve as much energy as possible. At this point, the skies have cleared, so we're trying to see if we can reestablish communication. We think if nothing has broken, we should be able to do that, but we haven't communicated with the rover for some time now, so we're not entirely sure what's going to happen. We do know that there's a period of time where it's going to start to be really windy, and especially if we're coated in the thin layer of dust on our solar panels, if the winds pick up and move that dust off our solar panels, we still might hear from Opportunity. So we're all keeping our fingers crossed for this particular rover, and we hope we hear from her very soon. But I want to pause a little bit and just talk to you guys about why I love Opportunity so much, and to emphasize how long this rover has been going. This is my favorite picture of Mars of all time. This is what Opportunity saw, kind of the first pictures that she sent down after she landed. And when I saw this picture, I was in high school, so a little bit older than you guys, but not much older. And it totally captivated me. Up until now, all the pictures that I'd seen of the Martian surface and that anyone had seen of the Martian surface were really rocky and dusty. And here was something completely new, completely different. It's very dark. There's not a lot of big rocks. And I realized looking at this picture, I really felt like I was an explorer seeing new terrain for the first time. And really exciting about this image is you can see these light colored rocks off in the distance. And this is actually what geologists call bedrock. And this is really exciting because it's rock that formed in place, and it tells you something fundamental about the environment that it's in. And there's actually a picture of me. I got to be at the Jet Propulsion Laboratory the night these images came down, and it was so exciting. And this is the picture where I am deciding that for the rest of my life, I want to drive rovers on Mars too and be a Martian explorer. And there's a lot of words on this slide, so I won't go through it all. But this is a figure that represents just how long Opportunity has been going. And what I've done is I've labeled the traverse of Opportunity with the things that I've done in my life to get me from high school to working at JPL. So Opportunity landed up here in Eagle Crater when I was a high school junior. And throughout that time, as it drove along, I went to college. I graduated from college. I got a degree in geology and in physics. I went to graduate school. I started working on this rover as a graduate student, got a master's degree. Then I got my PhD in Earth and planetary science. I moved over to start something called a postdoc, which is a position you do after getting your PhD. I did that for a couple of years. Then I got hired by JPL and started as a research scientist. And then I was appointed as the deputy project scientist for this rover. So for a mission that was supposed to last for 3 months, I think it's gone a really long time, and I think it's really neat to track my career with this rover. But what am I doing today is I'm spending a lot of time on the next rover NASA landed, which is the Curiosity Mars rover. Here's a picture of Curiosity, and if Opportunity was our robot geologist, Curiosity is our robotic chemist. We have a lot of really interesting analytical instruments inside the rover. For comparison, here's the size of the rovers, and I have actually a wheel from Curiosity I can show you in a minute just how big it is. But you can see the size of Opportunity kind of off to the side here. Our first rover to Mars, Pathfinder, is this tiny little thing in front, but Curiosity is huge. It's a very big, very sophisticated rover. We landed in this big crater on Mars that was interesting because there's this stack of rocks in the middle of the crater, and we wanted to study them because we thought they were put down by a process that makes layered rocks that probably involved water. This was our first view of that mountain when we landed in the crater off in the distance. And as we drove along the way, we saw these really cool rocks on the surface that had these rounded pebbles in them. And we realized that these rocks look a lot like river rocks. This rock on the right, or image on the right, is from Earth. And these are rocks that you find in rivers. And we think what we see on Mars was really similar. When we looked closer at the mound, we saw it was indeed very layered. And as we got even closer, we saw that these layers were really fine grained. So putting all of this evidence together, we realized that this crater that we landed in used to be an ancient lake. So this had a lot more water than the Opportunity site had. And this had water that we think was probably good for life in the distant past. Even more exciting, when we drilled a sample of this lake and we put it into the analytical instruments inside of Curiosity, we found what are called organic molecules. These aren't molecules that tell us life was here, but they are molecules that life is made out of. So we know now all of the necessary ingredients for life were present at this site. Just wrapping up, here's the picture that came down from Curiosity this morning. This is what I spent my morning looking at and thinking about, and it's actually a very exciting time on the mission. We're going to try to drill this afternoon into this rock to see what it's made of, see if there's any organic molecules or any other indicators that tell us this could have been a habitable place. So, you know, stay tuned, check out tomorrow to see, did our drill hole work? Sometimes it works and sometimes it doesn't. Drilling on Mars is really hard. But I'll just wrap up by showing a little bit more about what we plan to do for the future of Mars. So actually in about 3 weeks, we're going to have a very exciting event where we're going to land another mission on Mars called the InSight mission. This is going to be a lander. It's not going to have wheels like the rovers, but it's going to have a really deep drill, and it's going to be able to go into the inside of Mars to measure some important information about what the planet is like on the inside. How big is the core? How thick is the crust? Questions like these. Then in 2 years, we're going to be launching a whole fleet of spacecraft to Mars. Both the United States and Europe and China and the United Arab Emirates all have plans to send robotic spacecraft to explore Mars. So I'm very excited about the future of Mars. And then just to leave this slide up for a little bit, if you guys are interested in exploring Mars by the seat of your pants, you can actually follow along with Curiosity data real time. Curiosity has mission updates that we provide every time we do a day that we plan science on Mars. We write a little blog post about what we did that day. Sometimes I get to write the blog, so I'm in there a little bit. And then also every single image that Curiosity takes is posted to the web virtually real time. So just like us, you can be some of the first humans on the entire planet to see these images of Mars. You can just go to this site, mars.nasa.gov/msl/multimedia/raw. So that's what I had for you guys. I will stop sharing, but I can put these links in the chat if you're interested. Happy to take questions. I did bring one prop I wanted to show just to give you a sense of how big Curiosity is. This is one of the wheels of Curiosity, and you can see it's bigger than my head. So, you know, we have 6 of these that we're driving around on Mars. So this gives you a sense of how big and how awesome the Curiosity rover is.
Very cool. So much. That was I think it's kind of that like a summer or like distant history to all the kids who aren't even 14 yet. Makes you feel old. Oh well. All right. Well, if you're good for questions, let's start with Miss Caesar's class. If you guys have a question, come on up.
Do you think that we could bring water back to Mars somehow?
So the question, do you think we could bring water back to Mars?
Yeah.
Yeah. So certainly if we send humans to explore Mars, we're going to want to bring water with them. Humans need water to survive. We do know that there is a lot of water on Mars today. It's just not liquid right now. So we have water that's water ice that we know is buried underneath the surface of Mars, and also at the poles. Some of the pole is made of water ice. There's a little bit of water in the atmosphere, and some of the water is actually trapped in the rocks and minerals. So we'll either have to bring water with us for humans, or we'll have to figure out technologies that can extract the water that's on Mars and turn it into something that's liquid and drinkable and usable.
Very cool. Before we go to our second classroom, I want to mention too, we have quite a few groups watching live on YouTube Live. If you guys want to pass on your questions in the chat bar on the right of that, you're welcome to, and we can pass them on to Dr. Fraeman from there. All right, let's go to Miss Creech's class. You guys have a question?
I don't think, can you hear us?
No. Yep.
Oh, great. Okay, Ruby. First one.
How does the rover break down from the spaceship into a little rover?
Yeah, that's a really good question. How does the rover leave the spaceship and turn into a rover? There's a whole very complicated process that we call entry, descent, and landing, which is basically how we take the rover as it's packaged on the rocket and we land it on the surface of Mars. For Spirit and Opportunity, we had this very intense kind of origami type thing. We had the rover all packed up into a very special kind of a pyramid looking thing, and we inflated big airbags around it. So when it landed, it just kind of bounced around on the surface. And then when it stopped bouncing, we deflated the airbags, we opened up the origami pedal, and there was this whole series of things that had to happen where the solar panels had to deploy and the mast had to come up and the wheels came out. For Curiosity, it was so big we couldn't land it with the airbags, they would have popped. So instead, we used something called the sky crane, which is basically we lowered it from a crane out of the sky as it was landing. And in that case, we had several different things that had to happen as well. The wheels came out, the rockets fired, but the engineers here are very good and they figured out a way to do all of that, and it landed successfully.
Outstanding. I'm so glad that question got asked. Sky crane is such a neat thing. All right, let's go to Ms. Zamora's group. Go for it, guys. Everybody's got a question in that class.
My name is Kaylee, and I was wondering, so in LEGO Robotics, we are studying problems that astronauts face in space. We want to find ways to help astronauts who are homesick. Do astronauts use VR in space? And if so, how?
Yeah, that's a great question. I think homesickness for astronauts is a really good question. You know, astronauts orbiting Earth, they can talk to their friends and family, but when you get out to Mars, Mars is so far away, it takes 20 minutes for a signal to get from Earth to Mars sometimes. So you couldn't have a real-time conversation. But yeah, I think using VR would be a great way to combat homesickness. The astronauts on the space station actually tested out some VR headsets, not to look at homesickness, but to look at if we could communicate better with Earth on how to do things like repairs on the space station. So they used, it was the Microsoft HoloLens, and you can look this up online. I think the program was called Sidekick. And astronaut Scott Kelly actually tested it out on the International Space Station to use it to help do things like repairs around the space station. And that technology was actually developed at JPL with collaboration with Microsoft.
Outstanding. And for that class too, what a great question, and one we didn't really expect. If you want, on November 15th, we actually have a hangout with an astronaut who's been to space. So if you want to come in, even if you have to get on YouTube Live, you can ask that question again. Highly recommended at 11 a.m. Eastern. All right, Miss McCrell's class, I don't know if your mic's working yet. We'll check in with you guys, see if it's working. If we can hear you, great. If not, you might have to type in your question in the top left. So can we hear you? Maybe, maybe not. I don't think so. So Miss McCrell's class, no? Okay, we'll come back. We'll see. Try and use that chat bar in the top left, little blue square. But for now, we'll go to Mr. LeVog's class. If you want to demute your mic, you can go and ask a question. There we go. Good.
Go ahead.
Hi, I'm Ruby. I was wondering, what classes did you take during your education that helped you get set up to work for NASA and work for Jet Propulsion? Like, what helped you get to your career?
Yeah, that's an excellent question. So taking math and science classes, as you can probably guess, I think were really important. Computer science classes also helped a lot, learning to program. Programming is something that I do a lot in my job as a scientist to help me analyze data, and I'm really glad I had the opportunity to take that in high school and learn that skill because I use it all the time. I also think it was important to take classes that you might not think of, especially classes related to English and communications, because as a scientist, a lot of what I spend my job doing is writing papers, presenting my research to other scientists at conferences. And so the ability to effectively communicate the science that I'm doing is just as important as the ability to be able to do the science and the ability to have that math and that physics background.
Outstanding. All right, and then last but not least, in our first round of questions, we'll go to Miss Williams' group. If you guys have a question, come on up and demute your mic.
So, my name is Abigail, and we were watching a little NASA movie about some things on Mars and the solar system, and it said that in the past they found traces of water on Mars, and now they're wondering, or they haven't found any traces of water on Mars today. And I was wondering if you knew or had like a theory of how the water disappeared on Mars.
Yeah, that's something that we're actively studying today. So we do know there is some frozen water on Mars and there's some water in the atmosphere. So there is water on Mars, but we do think in the past there was a lot more water on Mars. And as I showed, some of the data we're finding with Opportunity and Curiosity and many other missions is telling us that there was a lot of liquid water on the surface of Mars. So a big question, and why I think it's important to continue studying Mars, is where did all that water go? Some of it's there, but a lot of it was lost. We think some of it might be trapped in the minerals on the surface and in the soil. And some of it was probably lost to space. We have an orbiter right now that's studying the Martian atmosphere, and it can see that the Martian atmosphere is getting weaker and weaker. It's losing a little bit of atmosphere over time. And so we think if you integrate that back billions of years, you probably lost a lot more of the atmosphere and you lost some of the water with it. So the question is, what was the original amount of water on Mars? How much was lost to space? How much is trapped in the rocks and in the ice underneath the rocks? And we don't know the answer, and we're really interested in finding that out.
Excellent. I love how the classes have done all this pre-research and watched videos and done stuff. It's been really good.
It's a great question.
Yeah. So we're going to do another round of questions. Dr. Fraeman, is that okay if we do another 6 questions? Are you good?
Absolutely.
Cool. So Ms. McCrell's class, I know we're not working with the mic or the chat bar. If you want to pass along questions in an email to me, I will pass them on. So send an email to me back where I sent you the original link, and we'll go from there. But for now, Ms. Caesar's class, if you guys have a question, come on up.
He's coming.
Yep, all good.
So what technology is being made to help humans survive on Mars?
Yeah, so what technology is being made to help humans survive on Mars? I think there's a lot of things that we need to do to get humans to survive. One of the big obvious things is inventing a spacesuit that's going to be good for humans to walk around in the Martian environment. And also, hopefully, that might protect you a little bit from the radiation that you get on the Martian surface. Technologies for the habitats, you know, how would you build a shelter that humans could live in, especially when you get a really bad radiation event? There's not a lot to protect you on Mars. So where would you go in order to stay safe? And how would you build something that's light enough to carry to Mars, but strong enough to protect you? And then one of the technologies that I'm really interested in is technologies to extract some of these resources that might already be on Mars. So we talked a lot about water. So what sort of instruments could you build that could extract water that's already on Mars, but not necessarily drinkable? And, you know, could that save you the hassle of bringing your own water? Because you would need to bring a lot of water. So I think all of those technologies are going to be really important.
Very cool. All right, let's go to Miss Creech's group again.
I was wondering, how sharp are the rocks on Mars and how easily could they puncture a spacesuit?
How sharp are the rocks on Mars? Well, it depends where on Mars you are. If you're at a place like where Opportunity was with those nice, dark, smooth surfaces, there's not a lot of sharp rocks. But actually, if you land in a place where Curiosity landed, we found that there's a lot of sharp rocks. And actually, not only would they give spacesuits a problem, they're giving us a problem in our wheels. And I showed you, the wheel is big, but it's also very, very thin. And this is a plastic wheel, but the actual wheel on the rover is made of aluminum. And it's really thin aluminum. And it turned out the aluminum on those wheels are too thin. And the rocks were actually poking big holes in our wheels. So if you look at the pictures of Curiosity's wheels today, there's big holes and tears that the rocks have done. So we've had to do a lot of work on our end to try and figure out where to drive, where the rocks are going to be less sharp and less damaging to the wheel. We've also worked with the engineers who figured out better ways to drive so that the forces on the wheels aren't as strong. And for the next Mars rover that we're building, we had to totally redesign the wheels to make sure that the rocks don't tear them up. So yeah, those rocks for a spacesuit, I'd be very concerned about. You'd have to be smart in how you design the spacesuit, and then also as an astronaut, where you walk so you don't fall down.
Very cool. All right, Miss Zamora's group.
Introduce yourself, friend.
Hi, my name is Daniel. If there was another sandstorm for the rover, how would you prevent it from shutting it down?
Yeah, so unfortunately, there's nothing we can do. If there's another dust storm that kicks up, there's nothing we can do. Remember, Opportunity was only built to last for 3 months. So it's already far exceeded how long we built it to last. So we're kind of at the point now where we're just running it on borrowed time. And if something happens like this, or if we don't get it back today, we're still really happy with how well it worked. Curiosity, it's not as much as a problem because Curiosity doesn't have solar panels. It's powered by nuclear power. There's a piece of plutonium in Curiosity that powers its battery. And so we can have all the dust storms we want and Curiosity won't notice it, other than it gets a little bit darker, so we have to expose our pictures a little bit longer.
Awesome. I think Miss McCrell's group might actually have a working mic right now. Try and say something. If you guys have any questions, I don't know. Just like a little feedback anyway. I really want you guys to get a question in. I don't know. Okay, we'll come back. Mr. LeVog's group, if you guys have a question, come on up and demute your mic.
Hi, my name is Marina, and I wanted to know what is one of your biggest discoveries?
Oh, so me personally, or are you thinking Mars overall?
Both.
Both. All right, so for me personally, when I was a graduate student, I was mapping from orbit some of the areas that Curiosity was going to visit and hadn't visited yet. And I found a signature of a mineral called hematite in the orbital data. And it's an important mineral because it forms in water and it forms in very specific chemical conditions in water. So I was the one who first discovered and mapped it, which was really exciting. And now I'm actually leading the campaign for the rover. We're in that spot where I found from orbit. Trying to figure out what happened. And we're actually seeing things that are different from what we saw from orbit and some things that are the same. And so it's been really fun to have discovered this area and are now kind of helping dictate the science observations we make down there. I think in general in Mars, we've made so many really awesome discoveries. And I think in the last 10 years, kind of our view of Mars has fundamentally changed. A lot of thanks goes to the orbiting instruments that have shown us that there's all of these minerals all over the surface of Mars that had to form in the presence of water in the past. But even beyond that, we're finding that all of these minerals probably formed in different kinds of geologic environments. So we found hot springs and lakes and rivers and deltas and probably some hot water moving underneath the surface and hydrothermal systems. And it's just a hugely diverse planet. And I don't think we really appreciated how diverse Mars was until we started getting these data kind of in the last decade.
Very cool. All right, and then we'll wrap up with one last question with Miss Williams' group. Do you guys want to come up? And you're good.
Hi, my name is Alexandria, and I was wondering, based on the data you found that there was water and there was life minerals, do you think you're going to be able to grow plants on Mars?
Oh, yeah. Can we grow plants on Mars? I don't know if any of you guys have seen the movie The Martian, but it's an astronaut who gets stuck on Mars. Yeah, and he grows potatoes. So we get asked that a lot. Could you grow potatoes on Mars? And personally, I think you could. There are some chemicals in the soil that might be a little bit nasty. There's something called perchlorate that isn't so great for life. But in general, I think the soil is kind of like soil you might find in a place like Hawaii. So I think if you brought enough fertilizer and you brought enough water, why not?
Right. All right. Dr. Fraeman, before we wrap up, is there any last message you want to share with classes, how they can learn more, how they can become like you, anything you want to kick us off with?
Yeah, just thank you guys so much for listening in. It's been so nice talking to you all and hearing all your questions. I love my job. I feel so lucky I get to do this every day. And I think if you're interested in space or in exploring, which I certainly was when I was your age, just continue to be curious about your environment. Study things in school that really interest you. Study them because they're interesting to you, not because you think you have to. And you can certainly learn more online all about curiosity and about Mars. You can even just Google Curiosity updates or Curiosity raw images, or go to that mars.jpl.nasa.gov website.
Very cool. All right. So what we do at the end of every Hangout is I'm going to demute everyone's microphone. So Miss Caesar's class, Miss Creech's class, Miss Zamora's class, Mr. LeBeau's class, William, and Ms. McCrell, if you guys could join me in saying thank you. Appropriately. Awesome, guys. For the classes, we've got tons more space hangouts all month long, and of course, we do hangouts on all manner of sciences all year long. Dr. Fraeman, that was outstanding. We loved having you and look forward to having you back as soon as you like. All right. So, yeah.